Okay, since you've been gone and you're not going to come back anytime soon, at least we're not going to go back anytime soon that I can see, I'm going to do the test 5.1. This is the test you did right before spring break. So, here it is, in case you wanted to see what was happening there, and we'll just go over it. So, in this question, let's scroll up a little bit. The following diagram shows a circle with a center of 0 and a radius of 3, okay? So we're going to find the length of the arc ABC, which is right here. ABC arc. Okay. All right, then. So arc length, if you recall, we're going to do part A. We're going to answer these in the boxes here. Okay. The arc length, which I usually call L, let's call this L. That's how I usually do it, is going to equal R times theta. That's always the case. So R, they tell me, is 3, and theta is 1.3. So we'll just put that, well, actually, I don't need to put that in the calculator. It's going to be 3.9, actually. 3.9. And that will be in what unit? Centimeters. Okay. Very straightforward, simple question. Okay. Find the length, find the area of the shaded region. Okay, the area of a shaded region has another formula that goes with it. This is going to be 1/2 R squared theta. Okay, and the shaded, this, when we say the arc though, when we say the, when we say the angle theta, we're talking about this angle that incorporates the shaded region, so not the 1.3. So if you recall, the entire circle has an angle of 2 pi. So we're going to subtract the 1.3, and this is going to be my theta. This is what I'm going to have here for that. So be careful with that. Okay, so it's going to be 1/2. And then we have 3 squared, and then we have 2 pi minus 1.3, and then we will put that in the calculator. Let's clear this off. Okay, so we're going to do 0.5 times 3 squared, which is 9 basically, and then times 2 pi, where's pi, 2 pi minus 1.3, and this will be 22.4 about. If you round to 3 significant figures. And this will be in cubic, I'm sorry, square centimeters. And that's your answer for that one, okay? Number 2, this one was a nice tricky question. In fact, so much in fact that I actually don't think I took off any points for this particular question, but I'll show you how to do it anyway. It's going to just require a calculator. These are all paper 2 questions, so they all require calculators, where you're allowed to have a calculator. They don't really require one, but so there you go. Let f of x equal natural log of x squared for x is not equal to 0. Show that this is the derivative of f of x. Okay, so if I go ahead and do this, part A, I have f of x equaling natural log of x squared. Okie doke. So in this particular case, what I'm going to do is a chain rule. Okay, so the chain rule tells me that the derivative, we're going to take the derivative of the natural log, which we know is 1 over x, but instead of putting x, we're going to put whatever's inside here on the bottom, which is x squared. And then we're going to multiply it by the derivative of the inside, okay, by chain rule. So the derivative of x squared is actually 2x. So what I now have is 2x over x squared. And what that will give me, of course, is going to be 2 over x. And this is what they wanted me to show right here. So that's how you do that, okay? A little bit of elementary calculus. So right here, this is the fun part. The tangent of the graph of f at a point d, and f of d passes through another point 1 and -3. Find the value of d. Okay, so this is kind of tricky because we're going to have to use the point slope formula. And we've done some questions like this on homeworks, but it's easy to forget these. So here's the deal. In this particular case, if I have a tangent on some sort of graph, okay, and technically this is the graph of f right here, so if you actually wanted to, you could just get out a calculator and see what that graph looks like, since you have a calculator. And we'll just do the scratch pad here, I guess, and let's graph the natural log of x squared. And it looks like a weird thing here. It's a strange looking graph, right? Okay, so the question though, let's go back to it, is there's a tangent on that graph somewhere that passes through 1 and -3. So 1 and -3 will be down like here somewhere, okay? So let's talk about that. So a tangent will pass through there. So if a tangent is going to pass through 1 and -3, which is like down here somewhere, then we're looking at a point over here where there's a tangent here. So there's a point right here somewhere where if I were to draw a line, it would go through this other point that I need. And that's kind of what's happening, okay? So here's the dealio. If we have a point here, let's actually do a little sketch then. And technically I should be doing this in the box, but I'm not going to. So let's say I have a point here that's, this is your point Q, which is your 1 and -3. And then I have another point here where there's a tangent that goes through both of them. And this point here is called P, is what they're telling me. Okay, so they're calling this D and F of D, so that's fine. We call it D and F of D. And this, of course, this point Q right here will be 1 and -3. So what they want is to find the value of D. Okay, so here's the deal. Or this x coordinate, pretty much. Okay, so what we're going to do is we're going to say, all right, this right here is my x1 and my y1. We'll call that x1 and my y1 for this formula right here. So what I have here is y minus d, I'm sorry, minus f of d. Let's get rid of that. It's a y value. And the slope, this is the slope of a tangent line, and the slope of the tangent line is this. We're just plugging in this x value into this derivative, but that x value is d, so that means that my slope is actually going to be 2 over d, is what that means, okay? And then we have now x minus x1, which is x minus d here, because that's the x value I'm using for x1. Now, all I have to do now is plug in a value for x and for y, and that x value for x and y, sorry, that values for x and y will be 1 and -3. So we will plug those in. So I'll have a -3 minus f of d equals 2 over d times x, which we know is 1 minus d. Now f of d though, remember what is f? F is natural log of x squared. So really what that actually is the natural log of d squared now. Natural log of d squared. And then this is really the equation that you're going to have to use to solve for d. Which seems kind of horrendous, but once we have this equation, we can just put it in the calculator and solve it for d. And that's all you really can do, honestly, guys. So if we were to do that, let's hit escape here. What we have here is we're going to go to menu, algebra, numerical solve. This will be -3 minus natural log, natural log of, didn't go to the right button, there we go, d squared equals, control divide, 2 over d, 2 over d times 1 minus d. And then we're going to hit comma. We're trying to solve for d. Let's make sure that's correct. Looks good to me. Okay, and I'll hit enter. So your answer is going to be -1.3. Okay, and that's really all there is. -1.31, and that's your answer. There's not really anything else you could do. But that was a tricky question, and because of that, I think only maybe 2 or 3 people got that question right out of the 26 seniors I have. So I omitted the question anyway for being counted as toward the grade. So there you go. But that's how you would have done it. Here we go. Number 3. Given that the sine of x equals 3/4, where the angle is obtuse, this is very important. Find the value. Angle x is obtuse. Find the value of cosine of x. Okay, so if I were to imagine this, if I were to draw this little situation they're explaining to me, I have a sine of an angle. So let's say this angle right here. This is the angle x, they're calling it. It's obtuse. The sine of x, we'll use the reference angle for that, which is this guy right here. And the sine of x will be 3/4. So this is 3 and this is 4. Sine is opposite over hypotenuse, okay, for this right triangle. So, as it turns out, the cosine, we have to find this side right here, this missing side, and we'll have to use the Pythagorean theorem to do this. So here's what I'll say. I'll say that 4 squared is equal to 3. We'll call this x, or call this, we'll call it, I already called this angle x, so I don't want to confuse you. We'll call it p, I guess. I don't know. So this is going to be 3 squared plus p squared. So p squared will equal 4 squared minus 3 squared, which is 16, minus 9, which is 7. So p will equal the square root of 7. And we know now that the cosine of x is p/4, so it's going to be root 7. And actually, be careful here. When I say this is root 7, it's actually negative because this is the origin. So p is actually negative root 7 because we're going to the left of the origin. We're going in the negative x direction. So this is actually negative root 7/4. Okay. And that would be your answer for that one. Okay, and that's all there is for that. And we're going to do the next one here, which is cosine 2x. It's pretty straightforward now. I keep changing the color, but it doesn't want to change. That's interesting. Okay, so cosine of 2x will equal, there's 3 ways you could write this double angle formula. It's an identity. It's going to be cosine squared x minus sine squared x. That's one of the ways. There's 3 ways you could do that. And this will be my negative root 7/4 all squared. Negative that. And then they've already told me that sine is what? 3/4. So this is going to be minus 3/4 all squared. So what I'll have now is 7/16 minus 9/16, which is negative 2/16, which is negative 1/8. And that will be your answer for that one. Okay. Alright, let's get to the good stuff. I'm going to change my view here to a dual display since I have room. Since I'll need the room to work here. So here we go. So we're going to do number 4. These are fun questions. We have 2 graphs here, okay, that are shown. We got F and we got G. Parts of F and G are shown. They're the positive values, I guess, for these 2 graphs. It looks like G is a parabola, so it would go this way, I think, by the looks of things. Yeah, if it were not restricted to being greater or equal to 0. So they intersected the point P. We can see that. Okay, or it's P and Q. Find the values of P and Q. So this coordinate P has P and Q is that. Okay, so this is actually the easiest question because since you have a calculator and they give you the 2 equations, you could literally just graph them both and find out where they intersect, and that's all you really should do. Okay, so for A, this is just going to be calculator work. Let's just graph. So it's 9/x plus 2. Let's do that. Let's clear this. And we'll graph the first one, 9 over x plus 2. And the other one was 3x squared. And there we go. So we're only looking at the first quadrant here for the grid. That's what it looks like on our test. So we're going to go to menu, analyze graph, find the intersection point, lower bound, upper bound, highlight it. This answer for the coordinates will be 1, 3. The calculator's happy to help you there. And since you don't have time to waste, that's all you're going to put. We're going to say the intersection is for P is 1, 3. Okay, don't see them taking off points for that. Solving that algebraically is actually rather complicated, so don't waste time trying to do it, because you won't have time to do that. Okay, write down f prime of P. They want me to take the derivative of f and then plug in this value for P right here. This is little p, they call it. I really don't like it when they put P and P because it's confusing, but that's what they're going to do. So we're going to take the derivative first of f of x, and this is the function up here, f of x. So this is really a quotient rule, if you want to write it like that. So this is low, d high, the derivative of 9 is 0, minus high, which is 9, d low, which is 1, all over low, which is x plus 2 all squared. So this is really negative 9 over x plus 2 all squared. And now they want me to plug in f of p, which is, f prime of p, which is f prime of 1. So this is negative 9 over 1 plus 2 all squared. So this is negative 9 over 9. So this answer will be negative 1. And that would be your answer for part B. Okay. Let L be the normal to the graph of f at P. So there's going to be a normal line. There's a tangent line and a normal line. Okay, so when they say normal, it's a line that's perpendicular to a tangent. Find the find the equation of L. Give your answer in this form: y equals ax plus b, which is the same thing as mx plus b. Okay. So here's the deal. To find the normal to the graph of P, I need to find this tangent to the graph at P. As it turns out, I have already found the derivative of P, which is your slope of your tangent at P. So the opposite reciprocal of negative 1 is going to be positive 1. Okay, so slope of normal, so we're going to do this is going to be part C. Slope of normal will be m equals your slope, or A we'll call it, right? They call it A, I'll call it m, is going to equal 1. Okay, so here's the deal. I have the point is shared. The point P and Q right here is shared for both the tangent and the normal. You're supposed to know that. That's kind of what they're testing. Do you understand? Okay, so we have y equals mx plus b. We're just going to plug in the appropriate stuff. Okay, my m is 1. This is my x. This is my y. So I say 3 is equal to 1 times 1 plus b. That means that b is going to equal to 3 minus 1, which is 2. So your answer is just going to be x plus 2. And this will be it. It's the slope of your normal. I'm sorry, the equation of your normal. Okay. Write down the y-intercept of L. Okay. I don't know what the point of that was. We had to find the y-intercept of L to write the equation. Okay, I don't really, yeah. That's the strangest question I've ever seen. So this is part 1, and this is part 2. Unless they wanted me to leave it as b to begin with. I guess that's probably what they wanted. They probably wanted y equals x plus b. And then they wanted me to solve for b for the second part. I don't know. But the answer is obviously 2. We already found it. I already went the whole way there. So the y-intercept is, you could write that as 0, 2. There's the y-intercept. That's a strange question. Okay, anyway, is what it is. 4D. Let R be the region enclosed by the y-axis, the graph of G, and the line L. Find the area of R. Okay, so it's enclosed by the y-axis, the graph of G, which I have this, and the line L. So we don't see the line L, but we're gonna draw it. So the line L, understand here that this right here is the tangent line of the graph. L is a normal line, so be careful here. L is a normal line, so it's going to go perpendicular to this. So this is what L is going to do. It's going to go something like this. Okay. So this is enclosed by the y-axis, line L, and the graph of G. So we're actually finding, if this makes sense to you, this area right here, actually. This is the area we're finding. Okay, so that's a tricky question. We're finding that, which is called R, that area there. So, to do an area between two graphs, what we need to do is take the top graph, which is the line L, and subtract the bottom graph, which is in this case the graph G. That's the bottom. So what I need to do is take an integral between the boundaries, which is the y-axis, which is where x equals 0, and right here at P, where x is equal to 1. This is 1, 3. We already decided. So this will be bound between 0 and 1. Okay? So we need the integral between 0 and 1 of L minus the integral between 0 and 1 of G, and this will be with respect to x, both of them, dx. So you can kind of think of it like that if you wish. Okay. So here's what we're going to do. Let's extend this page so I don't have to keep running lower. Okay, so L we already know is x plus 2 with respect to x, is what they're asking me. And we're going to subtract g of x, which is 3x squared, which they gave me in the question. Okay, so we're going to do this. Alright, so to find this, we take an integral. So this, we're going to add 1 to the power and divide by the new power. This is going to be x squared over 2 plus 2x between 1 and 0. And then we're going to do the same thing here. We're going to have add 1 divided by the new power. This is going to be 3x cubed over 3 between 1 and 0. And of course you see the 3's cancel. Okay, so what I'm going to do is plug in this 1 here into both these x's. Okay, so this will give me 1/2 plus 2, and then I'll plug in the 0 into both x's and I'll subtract that. Of course that'll just give me 0. And then I will take this part, that's my top area, and I'll subtract the bottom area. So I'll plug in the 1 here, and this will be 1, and then I'll plug in the 0, which will just be 0, and this is what I have here. So not much happening with that one. Okay, and then I have this. So I have 2 plus 1/2. 2 is really 4 halves plus 1/2, so this is really 5 halves. 2 1/2 is 5 halves, and we're going to subtract 1. So this answer is going to be 3 halves when I do that, because 1 is 2 over 2. So this will be your answer for this question. That's the area. That's not much to that. Thought that was going to be more difficult, but there you go. Okay. All right, we're getting there. I think there's the last 2 questions. Yeah, here we go. So good stuff. All right, now this is a triangle problem, so maybe some trigonometry here. We'll see. I'm going to have to read all this. They kind of labeled them all for me. So we want me to find AC. Very good. AC. There it is. Found it. Right. Not really. So what I have here is I have an angle on an opposite side and another angle, and this will be its opposite side. So I'm going to use the law of sines to do this one. Part A. So here's what I'm going to tell you. I'm going to say that the sine of any angle over its opposite side is equal to the sine of any other angle over its opposite side. But they're calling this AC, right? So I'm going to say that AC, if I reverse it or if I flip all of the law of sine fractions, this is fine. AC over the sine of its opposite angle, which is sine of 44, will equal 15 over the sine of 83. Okay, you need to have an intuitive understanding how that works. So that means that AC, let's actually keep this in red. My AC right here is going to equal 15 times sine of 44 over sine of 83. So obviously your calculator needs to be in degree mode to do this, but that's what it's going to be. And I'll just put that on a calculator. That's a pretty easy question. Okay. And that's in degrees. Okay, so I will do that. I'll hit Control Divide 15 times sine of 44. Sine, oops. I'm trying to use my pen to do that, but it doesn't always register, so I'll use the mouse. You just have to listen to me click, unfortunately, but it's whatever. Sine of 83. So that's going to be 10.49. I'm going to say that's about 10.5. We'll just call that. Okay, 10.5. So that was part A. Find the area of the triangle ABC. Okay, so ABC. Now here's the great thing. Now that I know that this is 10.5, all I need to find the area of a triangle are two sides and the angle in between them. Now I have two sides right here, this side and this side. I already know these two sides. What I need to know is the angle in between them. But all the angles have to add up to 180. So I actually know what this angle is. It's 44, 83 added together. It's taken away from 180. So we'll just say, okay, what is 44 plus 83? That, we'll take that away from 180. Which you should be able to do in your head anyway. I'm just not. 53. That's 53 degrees. So, how you find the area of a triangle? It's 1/2 AB sine of C. And forget the formula. All that means is we just need 1/2 one side, which is now 10.5, times its adjacent side, which is 15, times the sine of the angle between them, which I now know is 53 degrees. So I can get this answer pretty quickly. Okay, so I'll do this with a calculator, clicky click. Times sine of 53. And that'll be 62.89, or let's call it 62.9 as we round. And that would be in square units, but since they don't give me any units anywhere, I don't see. Then we're, oh, that's in centimeters. Okay, so yeah, there we go. So this is in centimeters. I could see. That was also in centimeters. This is square centimeters. Okay. The area of the triangle ACD is half of the area of the triangle ABC. Ah, okay. Find the possible values of theta. Okay. So here's the deal. If it's half this area, the area of ABC, sorry, of ACD is half the area. It's going to be 62.9 divided by 2 then, right? So consult the calculator. I want that to be 31.45. Okay, so here's the deal. I now know that that 31.45 is going to equal to 1/2 remember, we have an angle theta. We have two adjacent sides, 6 and 10.5. That's the sides around that angle. So we have, this will be 6 times 10.5 times the sine of theta. So this is kind of a case where theta could be obtuse or it could be acute, because there's actually two possible values of sine theta that will satisfy this equation. So what I'm going to do is solve it for sine of theta. So you'll have to put this all in the calculator, of course. This is going to be 1/2 times 6 times 10.5. And we will do that. Okay, so we'll do this. We'll say, first of all, you know, I could just do that. Yeah. Here's what I'll do. So if this is the case, then what I have here now is that theta will equal really the sine inverse of that. Let's do it this way. So once I find that angle, I will take that answer and subtract it from 180, and that'll give me the other answer. So there's two possible answers. So I'll just make the calculator do it from here. So I'll say, okay, I'll do trig, sine inverse, and I'll make a control divide. And these are kind of strange questions. Like I said, you know, they're mildly tricky. You have to have a very good understanding of what's going on. Even though it's not really difficult, but a lot of kids will forget these things. So that's your first answer, and then we'll take that answer and subtract it from 180. So those are my two possible answers for theta. One of them is 86.8 and the other one is 93.2. And that's what they're looking for. Okay, so those are the possible values of theta. All right, getting there. Given that theta is obtuse, so they want the one that's obtuse, which is the greater of the two, 93.2. They're telling you that's what theta will be. Given that it's that one, find CD. Okay, so CD is this last side over here. And what I now know is this angle, this side, this side. So what I have here is a side angle side. It's a sassy triangle. So this is going to incorporate the law of cosines. So as you can see, they try to test you on everything and all of your rules in the same question, and they find ways to do this all the time. So my CD, there we go. My CD, I'm going to use this formula here. A squared is equal to B squared plus C squared minus 2BC cosine of A. This is the law of cosines. In this case, though, my A is actually going to be my side CD, so we can call it CD if you want. And B could be either one. It could be 6 or 10.5. We'll just call it the 6. 6 squared. C would be 10.5 in this case. Minus 2 times 6 times 10.5 times the cosine, and that's the angle we're going to use for the cosine, which is 93.2. And then we will solve this, right? We'll take the square root of this. So what we have to do is take the square root of both sides. Don't forget, a lot of people forget to take the square root on the end, and what they found was CD squared and not CD. So I'm going to just do that in the calculator with the square root in there, 93.2. So we'll just do that right away. So I'll do that. I'll say 6 squared. Oops. Plus 10.5, oops, 10.5 squared minus 2 times 6 times 10.5 times the cosine, all this, of 93.2. And that would be 12.4. I'm rounding everything, of course, but alright, and that'll be in centimeters, and that'll be your answer. So we are all done with number 5, finally. Number 6, let's just keep moving. Final question. Okay, a function f has its derivative given by this, so they gave you the derivative, or k is constant. They want you to take the second derivative. Okay, fine. The second derivative, which is the derivative of this guy, will equal 6x minus 2k, because you're taking the derivative with respect to x, so it's just minus 2k. That's it. 6x minus 2k. The derivative of negative 9 is nothing. It's 0. So that's it. That's your first question. Great. May they all be that easy. Okay. The graph of f has a point of inflection where x equals 1. Okay. Show that k is equal to 3. If it has a point of inflection, the graph of f, where x equals 1, that means that the second derivative at 1 will have to equal 0. That's kind of the rule there. And points of inflection happen where the second derivative equals 0. So what I now know is that if I plug in 1 into that x, I know that 6 times 1 minus 2k has to equal 0, because this is what this is equal to. So that means that 2k would have to equal 6, and then k would have to equal what? 3. And all they want me to do, getting text again, is prove that. They want me to prove that. So they want me to show that k is equal to 3. And there it is, k is equal to 3. Find f prime of negative 2. F prime, so that was, we just did part B there, guys. And I'll just keep changing colors, I guess. We'll go to C now. F prime of negative 2. So they actually already gave me the equation in the problem of f prime. They gave me this. Okay, but I now know that k is actually what? K is actually 3. So what I really have is 3x squared minus 6x minus 9. Since k is already 3, we already found that. So this is technically what I have. And all they want me to do now is plug in negative 2 into x. So this is 3, negative 2 squared minus 6 times negative 2 minus 9. And we'll solve. So this will be 4 times 3, which is 12, plus 12 minus 9. That's 24 minus 9. And that'll be 15. And that's your answer for part C. Okay, keep going. It's a never-ending fun house here. So find the equation of the tangent to the curve at negative 2, 1. Why do you think they just asked me to find f prime of negative 2? Because I just found the slope of that tangent. They are making me work in a systematic way to find the things I already need. So this is my slope for this tangent line they're about to ask me to find. Okay, so they want me to write the equation of this tangent at negative 2, 1. Give your answer in this form: y equals ax plus b. So I'm very popular today with all these text messages I'm getting. So my slope is 15, and the coordinate they want me to have is negative 2 and 1, and we're going to plug these in. So this is, A is my slope. They call this A, really. Okay, so that's going to be 15. X is negative 2, Y is 1. Only thing I don't know is B, and I'll solve for that. So it looks like B is going to equal 1, and this is going to be negative 30, so it's going to be plus 30, which is 31. So the equation that I am after is 15x plus 31. That's the equation of your tangent. Given that f prime of negative 1 equals 0, explain why the graph has a local maximum when x equals negative 1. Okay. I'm going to use the second derivative test to show you this. F prime of negative 1 equals 0. F double prime of negative 1, which I already found, guys. I think I already did this one. Way up here. No, a positive one I did. But what is f double prime? It's this. We know that k is equal to 3, so technically what this is equal is 6x minus 6. Okay, since k, we're plugging in this k into this 3 into k. And 6x minus 6 is my derivative, my second derivative. So this is going to be 6 times negative 1 minus 6. So this is going to give me negative 12. So because f double prime of negative 1 is less than 0, f of negative 1, actually let's write this as, ooh, come on. Giving you some justification here. because that is the case, f of x is concave down. At x equals -1. Therefore, f of x has a local maximum at x equals -1. So because it's concave down, x equals -1, it tells you that there's a local maximum there, okay? And that's your justification. This is called the second derivative test. And you really should independently do some research on that. Derivative. If I can't spell derivative, that's fine. Test. Looks like a P. Good grief. Okay. And that's what that means. So that's your answer. That's your justification for it. That's one way of doing it. You could have done a sign chart if you wanted to. I guess we could do that. If you were doing this, you could say that -1, this would have given you 0. You could have plugged in -2 and 0 into the derivative. If you plug in 0 into this derivative, you would have gotten a -9. Okay. Which is negative. It means it's concave down. I'm sorry, not concave down, but it means that the original graph is decreasing. And if you plug in -2 into this derivative, you would get a positive value. So you could say, okay, it goes from being positive to negative, so this had to be a maximum there. That's the first derivative test. So, I mean, they're just making you justify the maximum minimums there. That's all there really is to it. That's your whole test. So, thank you for watching that.